So here's a quick review on naming. Um, in Piazza, you will find in this box you'll find the link to, where you'll actually find this sort of study sheet for the final exam. If I'm going to ask you to name, or if naming is important, that I'm going to have to figure out a way to allow you to use something like this chart. But very simply, if we have a molecule that we need to name, this is the chart that we use to figure out what the highest precedence is in the molecule in terms of the chain and of the functional group. So this is the listing of the priorities of the functional groups from carboxylic acids all the way down to aryl and nitrile groups and alkyl, alkoxy, and halides, which really don't have any preference at all. Number one, you got to know your common names of your alkyl groups that were accepted. So just real quick, you need to remember methyl. I mean, at this point, if you don't remember methyl, it's going to be a long final exam. Then ethyl, and then of course anything that's a long chain is going to be that group. So there's propyl. Remember, we have isopropyl, we have butyl, we have isobutyl, we have tertibutyl, and then as far as the pentyls go, we have the 5-carbon pentyl, we have isopentyl, we have tertiary pentyl, and that's probably about it. So those are the groups that you need to remember their names, the names of. So if you want, you can stop this video and then write out the names, and I'll go ahead and put the names on here when I finally save this file. But when we're looking at this, we have two distinct situations. We have if we have a chain, or if it's attached to like a cyclohexane ring. So when you're looking at a molecule, let's say something like this. Let's say, just to illustrate, number one, you look at the functional groups that are present. You have a ketone present here, and you have an ester there. We come over the chart and we see that the ester is higher up than the ketone. So that means the ester is going to have the priority for the naming, meaning that its name comes last. So the ester name is going to come last. And also it gets the priority for numbering the carbon chain. So this is automatically carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. And typically any group that's automatically given a number 1 carbon position, you don't have to put the 1 in. So when we look at our ester over here, in this chart, we have to name the alkyl group that's attached to the alcohol portion of the carboxylic acid. And this should make a lot more sense now than it did back when we did this first semester. So that means this group is going to be an ethyl. So there's my ethyl, and now the question is, what is the chain? It's a 5-carbon chain, so it's going to be a pent. There are no double bonds in the chain, so remember it would be pent, ene, ane, or eine, but in this case Since there's no double bonds, this is going to be a pentan. And then when we look up here with the ester, when it's attached to a chain, which is in parentheses, it's an an O8. So this is a pentan O8 is the 5-carbon chain. And now we go through and we find out the groups that are attached to that 5-carbon chain and where they're attached and give them the appropriate name. Chlorine, no priority, it's the bottom. That's just simply going to be a 2-chloro group. Our numbering scheme is fixed by the fact that the ester has to be number 1. This group right here, 3, is a ketone group. We come over here to the ketone. When the ketone has the highest precedence, it goes in the naming over here. So if this was only a ketone, it would be a pentanone, but it's not. It's a substituent because it has a lower precedence, and so that makes it an oxo group. So this would be a 3-oxo. Now we just go ahead and create our list and put the name together. So this would be, first of all, the alkyl group of the ester. Now the list, 2-chloro. So this would be an ethyl 2-chloro, 3-oxo, and then the pentanoate. So that's how we use this chart in order to do that. The bold, or the italicized regular typing without the bold is what happens when it's attached to a chain, and then sometimes we switch the name when it's attached to a ring. So if we wanted to do a ring, for instance, I might have something like this, where I'd have maybe, let's say I've got a double bond, I've got an OH group here, and maybe I've got a carboxylic acid group down here, just to make things interesting. So now what we're going to do is now we look where the OH is. The OH, the alcohol, is here. The carboxylic acid has the highest precedence of all. That makes that carbon number 1. And then the double bond goes into the name. So we automatically have to start numbering at the carbon with the carboxylic acids because it's number 1 on this chart over here, being number 1. And so we would now go, we're going to go counterclockwise because we need to have the triple bond or the double bond in the numbering scheme and give it the lowest possible number. So in all of these cases, whatever the group is that's the highest priority gets the number 1 position. If they all have the same priority, then we look for the lowest total sum of the substituent numbers, and if there's more than one way to do that, we write or we number at the end that's first alphabetized. So in this case, this is going to be according to the name up here, this is attached to a ring, so it's a carboxylic acid with no Y. So this is the highest priority, so this is going to be a cyclohex. Now, because we've got the double bond here, we have to tell where is the double bond because this is going to be a cyclohexene. So typically we put the 2 in front to say this is a 2-cyclohexene. That tells you where the double bond is. And then this would be a carboxylic, and there's no Y, that is an actual I acid. So the parent name of this is 2-cyclohexene with the carboxylic acid automatically at number 1. For the other thing I've got to put in now is at carbon 4 I have an OH group. I come down here and I see that when an OH group is not the highest priority, it's called a hydroxyl group. So this would be a 4-hydroxyl 2-cyclohexene carboxylic acid. So that's how we use this chart in order to determine priorities on our different chains or on the rings. Basically a run-of-the-mill alkane, just to kind of remember that. If we had this chain, the first step is to find the longest continuous carbon chain. In this case, I would have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So this is going to be the longest continuous carbon chain in that molecule. I'm going to number at the end closest to the first substituent. If there's a tie, we give it to the end closest to the most number of substituents. Otherwise, it goes alphabetization. So this would go 1 and 2 and 3 and 4 and 5 and 6 and 7. And now we're just going to name and alphabetize the groups. So we've got a 5-methyl group, and we've got a 4-ethyl group, and we've got a 2-chloro group, and this is going to be a pentane, or sorry, a heptane, because it's 7 carbons. So this would be 2-chloro, 4-ethyl, 5-methyl heptane. If there was a double bond in here, in that molecule, if there was a double bond, let's say between carbons 3 and 4, the heptane would become a heptene, and then in front of the heptene would be the first number in that double bond. So that's kind of just a quick review of naming. You can always go back and look at much more detailed videos that I did. You can also go back into chapter 2 or 3 in Top Hat, where all of the naming rules are given. But in this case, this is the chart that I guess I would have to give you or allow you to use. Also remember in this case that even though the alkene comes higher priority than ine, in this case the ine, if you have a triple and a double bond, the ine comes first and the ene would come second. Okay, so if you have any further questions on this, feel free to ask, but this is kind of a very quick summary of the naming and how to use this chart in order to name complicated molecules.